A disk drive has been unreachable from time to time, saying searching for dollar and nothing happens. It has happened when the computer gets hot. In the previous video I have checked the CAs and swapped the 7406 logic IC. Here I'm trying to recreate the fault by letting the board get hot, but the power drops when the cable is wiggled at the power plug and connector. It drops quite a lot actually, therefore I have hooked up a voltage meter near the logic IC that drives some of the serial bus lines. I've seen low voltage here before, at 4.65 volts. Can the fault be on the board? The power connector needs cleaning. I had to improvise here using a Q-tip and a pin to clean the female contact. I also cleaned the male contact also. And it's quite fiddly doing this. So, but you get your alcohol and I had to use what I have actually. Make do, as they say. And bam! Instead of 200 millivolts drop I get a stable voltage. What the heck? I can't load from tape anymore. Here I'm loading game on turbo tape, but when the disk drive is on, there is no stripes on the screen. Switching off, and the stripes return. And switching on again, no stripes, no data. Here I try my other disk drive, no problems there. It's a third-party drive that doesn't work with my disk drive for some reason. And I reconnect the first drive now with the Commodore dataset, no problems. So let's sum it up. We have problems with the following configuration. C64, a third-party tape drive, and one of the disk drives. And here you have C64, the Commodore tape drive, and the same disk drive, no problems here. And then you have Commodore 64 and the third party tape drive again, but doesn't seem to mind the other disk drive. So that's very strange. Let's look at what lines are common on the serial bus that the tape and disk drive shares. Actually, it is the SQR line, or cassette read as it is also called. The SQR signal is an input on the CIA chip to the disk connector and also the tape drive connector as data is coming from the tape. Yeah, and there's also a 3.3 kilo ohms pull-up resistor connected to 5 volt. That's interesting. We have to look further into that. Ray Carlson, a retired repair tech who still repairs Commodores at home. I'll link me in below. A very resourceful guy and likes to share. Here you can see he has shared his experience regarding the SQR line. While SQR was intended for device requesting attention from the computer, it was never used as intended. He discussed the use of it and that someone had trouble with tape loading in combination with a disk drive that is using the SQR for high-speed transfer to the Commodore 128. But on the C64 this is not used. He even suggested cutting the line in the C64 near the serial bus connector. Anyway, I don't have the drive he listed. He also experienced trouble with the SX64 computer, the portable one, freezing during loading. The reason was the floating SQ line. Floating input is a bad design. He added 3K3 pull-ups and problem was gone. The C64 has these pull-ups, but what about disk drives? Some of them do and some of them don't, and which I found very strange and makes me think they patched this design fault in the C64 and VIC-20, who didn't have the pull-ups in that line, and it also makes me think maybe they pull too hard on the SQ line. So how would that affect my drives? Let's look at the datasheet for my 2 disk drives. Carlson's archives, information neatly stored. Sorted. Let's look at the 1541 early. I don't have this disk drive. There's no pull-up. And as you can see, the SQL line just feed through. And then you have the 1541 late. This one I have. No tape loading problems with this drive. And as you can see, no pull-ups, just feed through. And the other disk drive I have is 1541, and this one I have problems with the third-party drive anyway. And wow, here you can see the 1K in parallel here. So the tape drive must sink 5 milliamps for every disk drive added. That's ridiculous. Oh. So the disk drive, what can we do here? The 1K is whacked in the resistor pack. Why not the 3K3 moving on? The disk drive, what can we do here? The 1K resistor is whacked in a resistor pack. Why not the 3K3? Oh well, moving on. That looks familiar. Wire secure, no point in opening that way. There is a place sensor switch and wires in the way. And the board will come loose if we unscrew the sensor. And yeah, so let's do that. And here you can see, yeah, it's an inverter and an op-amp package. Nothing new here. Let's go back to the schematics again, or the diagram. The third-party tape drive, and then you have the MC14584 driver, and then the commdore tape drive, and the driver in that drive has a 74LS14 driver. Actually, these drivers are inverters. Here I have the dataset for the IC. This IC takes slow rising signals, like from tape, and makes them faster such that the signal look more defined. Hence the Schmidt trigger and hysteresis. Anyway, this is not what we are interested in here. Maximum ratings. 10 milliamp per max per pin. Interesting. And furthermore, with the drive attached, we are expecting 6.5 milliamp draw from the pull-ups. That's 5 milliamp to the drive and 1.5 to the C64. Here you can see we are somewhere in between these two conditions, and the output low voltage you can see on the left isn't very good. Somewhere between 1.5 and 1.5 typical. This particular chip is pretty old also, and by pushing it to the limit it will perform even worse. At 1.5 milliamp though, the voltage should be okay. Here's the IC that the Commodore dataset uses, the 74LS14. First of all, it happens to be pin compatible with the MC14584. Here we see that 6.5 milliamp is child's play for this device, even at syncing 8 milliamps. Oh, this solder flux smells terrible. Smells like cat piss, actually. I wonder what they used back in the day. There, it's in. So let's try it. Let's summarize first in total. So let's see here. We have the two resistors, one in the Commodore 64 and one in the disk drive. And you can add another one if you add another disk drive. And here you have the driver, and it has to sync 6.5 milliamps. It's okay for the Commodore dataset, but not for the third-party brand. Well, let's see how it performs now. The disk drive is on, by the way, and it is effectively pulling on the line. So, let me just load the turbo tape first. I don't know, I love turbo tape so much. There, no problems. It finds the program. So, I'm happy. And I'm happy, and now let's see what happens if you run it. Haha, jumping guy on the screen. Before binning this sucker, let's test it. Some resistor to simulate the pull-ups introduced by the Commodore 64 to 6K8 in parallel is 3.4, so that's close enough. And here are two for the two disk drives and a second disk drive, why not? So here's a long lead to hook the input to high and low voltage, so just for convenience. And all the inputs are now at ground. I'm just testing the 3K3, which is 3K4 actually, but that's okay, fine. So let's connect the rails together. So actually this part I think is quite fun, to hook up stuff. So here I have the meter connected to the output of the driver.
Okay, I hooked up power here. Jeg filmer faen ikke.
Power on, no smoke. Input to high, output is 0.63 volts. And input to low, we see
Fra minus til pluss.
5 volts, so that's fine.
0,6 volt.
Actually, this is already quite high, don't you think? For a 3K3 pull-up. So here we add another 1K to simulate the disk drive. Whoa, 3.2 way out of spec. So what if we add a second disk drive here? Oh my god, 4 volts. Okay. So I pull them out again, and now let's try the other chip, the Commodore uses. Actually, I think there's something wrong with the chip. And it behaves much worse than what the datasheet indicates. Oops, I forgot to switch the power off. But I hit the correct pins there, so yeah, we all do mistakes. 0.1 volt, great, that's very good. Low input, no problems. High input, let's see, low input, 5 volt, that's fine. It's an inverter, so it behaves as expected. So let's add 1 kilo ohm as if we attach the disk drive. So I connect it to the output and then the other end to the 5 volt as a pull up. So 0.9 volt. Alright, it works, it's within spec. It's not particularly good, but it's holding the line low. So yeah, let's try another one. This is like adding a second disk drive. So yeah, still within specs. Or within logic low level anyway. So there you go. Maybe the MC chip was faulty. Who knows? Problemless. So thank you for watching and see you next time. I hope this video wasn't too lengthy and difficult to follow. So I spent a lot of time on it to make it watchable. So wish you all the best.